This lesson is about arithmetic sequences and series, so we're going to combine both sequences and series into just dealing with a special case of the arithmetic sequences. So here we have what the definition of an arithmetic sequence is. The difference in consecutive terms is what we call constant. Difference means when you're subtracting two terms. So if you have two consecutive terms and when you subtract the different ones, they all turn out to be constant, the same, then it is arithmetic. The constant difference is what we call the common difference, and that's labeled with the variable d. So here in number 1, the first thing I want to do is figure out if I subtract these terms, negative 3 and 1, when you subtract them, you end up getting just 4, or you're adding 4 to each one. So from negative 3 to 4, that's a difference of 4. 1 to 5 is 4. 5 to 9 is 4. 9 to 13 is 4. So yes, this is arithmetic. So for the next one, from 2 to 5 is 3. 5 to 10 is adding 5. Then 7. And right there I can tell you that I'm not adding the same or subtracting the same numbers, so this one is not arithmetic. For the next two, negative 10 to negative 6, we're adding 4, and then adding 4 between negative 6 and negative 2. And then here's a change from negative 2 to 0, we're adding 2, and then 2 again, 4 and 4. So this one is not arithmetic, so what appeared at first to be arithmetic ends up not being arithmetic because of this plus 2 in the center here. And then the last one, from 5 to 9, or from 5 to 11, you're adding 6, adding 6, adding 6, and then adding 6. So this is a constant difference, so that is arithmetic. If you see that a sequence is arithmetic, or they tell you that is, then we have a formula to find the rule or the equation for it. So in general, a sub n, so any nth term that we want to find, is equal to a sub 1, which is the first term, plus n minus 1 times the common difference. N represents the term that we're at or what we're trying to find. And then there's an example here that you can take a minute to read, but we're going to go ahead and go over some of the problems below. In number 5, it says write a rule for the nth term of the sequence 50, 44, 38, 32, and then this is an infinite series sequence. Then find the a sub 20, so we have to find the 20th term. So the first thing I have to do is figure out this common difference. So from 50 to 44, you're subtracting 6, so our d value is negative 6 because our sequence is going down. So a sub n is equal to the first term, because if I see up here my formula up at the top, it says a sub 1, so that represents the first term, and our a sub 1 in this example is 50, because that's the first term of the sequence, plus n minus 1 times the common difference, which in this case is negative 6. I'm going to distribute the negative 6, and when you distribute that, you get negative 6n plus 6. Again, I just multiplied negative 6 times n, negative 6 times negative 1. And the last thing, I'm just going to combine my like terms. So you get a sub n in general is equal to negative 6n plus 56. So this is a rule for the nth term of the sequence. And then the second part of this question says to find a sub 20. So that means your n value is equal to 20. So I'm going to plug 20 into my equation we just found, where we found a sub n in general. So you'll have negative 6 times 20 plus 56, which turns out to be the 20th term is negative 64. For the next problem, we're going to find it pretty similar. So I'm going to help you find the common difference, and then I'm going to pause the video. We'd like you to pause it and come back and see if you can figure out if you got it right, if you got it wrong, and if you got it wrong, can you figure out what you did wrong? So let's find the common difference first. So 32 to 47, 32 to 47, that's increasing by 15. And then just double checking, from 47 to 62, that's also increasing by 15. So that means that your common difference is positive 15. So you're going to go ahead and plug in the common difference and your first term, which is 32, into the formula that you wrote up above. And here I found my general term, my nth rule, to be a sub n is equal to 15n plus 17. And then I went ahead and found the 12th term, a sub 12, by substituting the n value 12 into the equation we found. So 15 times 12 plus 17 was 197. In number 7, this is going to be a multiple step problem, so you want to make sure that you leave yourself enough room here. So one term of an arithmetic sequence is a sub 13 is 13. So that means that our n value is going to be 13 because that's the 13th term. And then that happens to be 30. And then the common difference is 3 divided by 2, so 1.5. Write a rule for the nth term of the sequence. So in order to find the equation, we need to figure out what the first term is. If we don't know what the first term is, we can't write the rule in general. So we're going to have to use that first piece of information to find a sub 1. So we're going to start off with a sub n. I'm just going to write down this formula that was on the previous page. A sub 1 plus n minus 1 times d. So again, we know a sub n because that happens to be 30. So we're going to use that a sub 13, which is, again, 30. A sub 1 is what we're trying to find in this first step. And then this is the 13th term. And we know the common difference is 3/2. So you have 30 is equal to a sub 1 plus, when you do this, you get 13 minus 1, which is 12. And 12 times 3/2, 12 times 3/2 is 18. So subtracting 18, you get your first term to be 12. So once we know what a sub 1 is, we can go ahead and just substitute that back in to that equation, now just using a sub n. So we have a sub n. Now we know that first term, a sub 1 is 12 plus n minus 1. We're back to using n because we're using the general form. And then 3/2. A sub n is equal to 12. And now distributing the 3/2, you get 3/2 n minus 3/2. And then I'm going to just combine my like terms. So we get 3/2 n. And then if I take 12 minus 3/2, combining those with a common denominator, you get positive 21 divided by 2. So 21/2 is what you get when you add 12 plus negative 3/2. So this would be the nth term of the sequence. For number 8, two terms of an arithmetic sequence are a sub 6 equals 10. So the 6th term is 10, and the 21st term is 55. Write a rule for the nth term of the sequence, and then after that we're going to find the value of n for which a sub n is equal to 40. So the first thing we want to do, just to kind of clarify, an arithmetic sequence, if you haven't figured it out already, is just going to be the equation of a linear function. So it will form a straight line, and it will have a common slope. So this the same slope from one point to the next. So if I can figure out the slope between these two points, then I can go ahead and that will be my common difference. So the common difference, again, I guess essentially is just the slope. So if I find the common difference, I'm going to take my outputs, which are my 10 and my 55, and I'm going to subtract them. That's the same thing as your y values when you find your slope. So 55 minus 10. And then my input values are going to be my x values in the slope, which is 21 and 6. So I'm going to subtract those. So you get 45 divided by 15. So our common difference in this problem happens to be 3. So now we're exactly at the same spot where we were in number 7. So once we figure out that our common difference is 3, we then have to go and figure out what our first term is. So you just choose, again, it doesn't matter, you can use the first term or the second term. I'm going to use a sub 6 is equal to 10 because, well, it's the first one, smaller numbers. There's no really rhyme or reason. You can pick the other one if you like. So I'm going to use this point right here. A sub 6 is equal to 10. So I know that my 10th term, I'm trying to find my first term. I know it's my 6th term, so my n value is 6. Again, I got that because in a sub 6, 6 is my n value. And then I now know my common difference. So you get a sub 1 is equal to 5 times 3. So the first term is negative 5. Once we figure out the first term, again, we're going to plug that back in to find our general equation. So let me label these steps here. So step number 1 was to find the common difference. Step number 2 was to figure out the first term. Step number 3 is to figure out your general equation now that we know those other pieces of information. So a sub n is equal to the first term, which was negative 5, plus n minus 1 times 3. So a sub n equals negative 5 plus 3n minus 3. So in general, we get 3n minus 8. So that is the rule for the nth term. And then it says, find the value for n which a sub n is equal to 40. So we're going to go ahead and, this is just a separate part of this problem. So this is to figure out a sub n is equal to 40. And I'm just plugging in 40 in place of a sub n, because that's what a sub n is equal to. 3n minus 8, and I'll solve this for n. So 48 is equal to 3n. That means that the 16th term is going to be 40. Here we're going to find the sum of a finite arithmetic sequence. Later on, we will work with geometric sequences and series. So right now we're just dealing with the sum of a finite arithmetic series. So here it says the sum of the first n terms, and here is a formula. You want to make sure you write it down. It's on the formula sheet that you get for the test and quizzes, so it's not something you have to memorize, but you do need to know how to use the numbers and the variables that are in here. So again, if we're trying to figure out, like for example number 9, in the arithmetic series, 4 plus 7 plus 10 plus 13 plus 19, or 16 plus 19, find the sum of the first 30 terms. So unless you really want to write out the first 30 terms and type them in your calculator individually, it's probably easier just to do this equation. So in order to figure out this equation, we need to know n, which is the number of terms, which we know is 30, a sub 1, which is the very first term, which we know is 4, We need to know this last term, a sub, in this case, the 30th term. So we don't know what a sub 30 is. So we're going to have to figure out what a sub 30 is before we actually figure out the sum. So to find a sub 30, we need to figure out the common difference, because we have to plug it into that formula we were just working with. So the common difference in this case is 3. So the first step is to find a sub 30. And in this case, our n value is 30. So I'm going to plug it into, again, that formula from before, the first term, which is 4, a sub 1, plus n minus 1, well, n is 30, times your common difference, which is 3. We found when we did 4 to 7, we subtracted them, we got 3. So a sub 30, the 30th term here, would be 4 plus 29 times 3, so which is 91. So now that we have all of that information, we're going to go ahead and do the second part of this problem. We're going to sum up the first 30 terms. So in using the formula, our n value is 30. So 30 is on the outside. A sub 1, which was 4 from the original problem, it was the first term, plus a sub 30, which is the last term in this series, we just found to be 91. We're going to divide that by 2. And when you type that into your calculator, you get a sub 30 to be 1,425. Number 10 is pretty similar. The sum of the first 18 terms of the arithmetic series, 100, 110, 120, 130. So again, I have to figure out the common difference, so I can figure out the 18th term in this case. So our common difference is 10. So again, step number 1 is to figure out what the 18th term, the last term of this series, is. So a sub 1 is 100, because that's our first term, plus n minus 1. N is 18 in this specific problem. 18 minus 1 times 10. That was our common difference. So our 18th term turns out to be 100 plus 17 times 10, or 270. So then step number 2 is to plug that information into this formula that's at the top of this page. We're summing up the first 18 problems, or 18 numbers. So n is 18, and then a sub 1 is 100, plus a sub 18 is 270. We just found that, divided by 2. So the sum of the first 18 numbers in this series would be 3,330 for a final answer. And this last problem says you're making a house of cards similar to the one shown. So here we have this nice little house of cards. Write a rule of the number of cards in the nth row if the top row is row 1. So if we're looking at this, this is the initial value. This is our a sub 1. So we want to know how many cards are in this top row. So if I count the cards, there are 3 cards in that first row. So I'm going to write 3 down. And then in the second row, if I want to count the cards, if you count them, you get 1, 2, 3, 4, 5, 6. So we're adding 6 more cards, so 6 is the next one. And in the bottom row, 1, 2, 3, 4, 5, 6, 7, 8, 9. There would be 9 in the third one. And then that's going to continue on. However, it's just looking for in general. So if I just look at this, our common difference is 3. And a sub 1 is 3. So if I want to write my general rule, a sub n is equal to the first term 3 plus n minus 1 times 3. So you get a sub n is equal to 3 plus 3n minus 3, or in general, an is equal to 3 times n. So that's our general equation. And then what is the total number of cards if the house of cards is 14 rows? So just like the previous problems, we have to figure out what a sub 14 is. The 14th row, how many cards there are. So again, a sub 1 is 3 plus our n value is 14 in this specific one. And again, our common difference is 3. So our last row would have 42 cards in it. So now if I wanted to add up all of the cards in the first 14, there will be 14. 3 is in the first row, 42 cards in the last one, and we'll divide that by 2. So the sum of the first 14 rows for cards would have 315 cards in them.